IPsec, policy-based, route-based, and even talks a bit and show you some SD-WAN. Then we'll also talk about the remote Ethernet device, or RED as we like to call them. So let's start off with remote client access. With IPsec, selectable WAN interfaces, be able to select which interface you want. If you have a dedicated internet connection for remote connectivity, that will help. Just like all other VPNs, we have our authentication for pre-shared key, or PSK, and digital certificate. And this is available through some of the methods of user authentication, like the local, built-in, the XG, AD, and even Radius, where you can get more extended features through there. Now, newer to the version 18 is the advanced settings of IPsec. These used to belong in the Sophos Connect admin client that is now legacy. This is now all in there. You no longer have to install another client to get these configurations. As you can see here, you can send the security heartbeat through the tunnel, and this becomes really important when you're trying to ensure the high level of security and you got your remote clients and they all have Sophos Intercept X on it. This will enhance your security posture. Also, we have on there prompting users for 2FA. This is very important in today's landscape, as a lot of users still like to reuse their passwords and they don't really utilize password managers, and if they do, they're just storing the same passwords. So 2FA is still a very big thing. We have Sophos Authenticator for that. And then we also have assign the DNS suffix. This is always one of those big things when you have users that are used to being in the office and now they're working remote and they're used to just going to file share and they never were putting in a DNS suffix. So you can put that in there so while they are connected to the VPN, they can still type file share in there and be able to get connected. Now onto SSL VPN. The SSL VPN utilizes the SSL encryption just like in HTTPS. We have the ability to do TCP or UDP, and this really comes down to what traffic you're using on there and how you're utilizing it. As specified, as you can see in the image, is UDP is best for performance, but there are some applications that really do like the TCP to ensure that maintain that connection. We also have the ability to customize the port on there. This becomes really important when you have a lot of inbound connections and other NATs that you're not using a port that is already in use. And we support clients like Sophos Connect client on Windows and OpenVPN. Now for clientless, we have our bookmarks, and we also have bookmark groups where it's a group of bookmarks. These bookmarks are configurable on the XG firewall, and you can configure them with protocols such as HTTP and HTTPS for web clients. We have the FTP suite with FTPS and SFTP. And then we do have SSH, Telnet, and RDP. This provides you the ability to configure and control and provide specific access to resources within a network behind the XG firewall. The XG firewall then will proxy this traffic through and give them access. This is really good when you have someone temporarily coming in that you do not want to have to install a client on, or they do not want to. Also provides just quick access to resources within the network. Some of the recent updates that have happened in version 18. In MR3 release, we did a 4 to 6 times increase in supported concurrent SSL VPN connections. This depends on the model you have. This is very important in today's time when you have a lot of remote workers out there and you do not have the budgets to buy bigger appliances to support this. We have optimized our firmware to ensure the capability of more SSL VPN sessions. Also, we have added support of groups for the Sophos Connect VPN client. Now you can create a group and add it to the Sophos Connect client, and then add users to it on the XG firewall. In MR4, we are now enforcing TLS 1.2. You can also, as you saw previously on the IPsec slide, is that you can now download the Sophos Connect VPN client directly from the XG firewall. And also, as you saw, is the new advanced options are now in there as well. Let's go over some remote access best practices. First, one of the obvious ones, configuring multi-factor authentication, or MFA, commonly referred to also as two-factor authentication, or 2FA, or OTP, and also TOTP, one time password. We have this via our Sophos Authenticator. We also support other authenticators. This is a Sophos product, so I suggest the Sophos Authenticator. One of the other big ones is provide access to only what is needed. If a user does not need access to the entire network of the office, you do not have to put You can create these via Microsoft CA or OpenSSL. This provides a higher level of protection on there, as you don't have a pre-shared key that can be potentially brute forced. Brute forcing over a period of time you may not realize, and then they have connection to your system. Now, one of the big ones is using remote client VPN over WAN HTTPS management. You'll see this throughout the XG firewall and the banners, especially when you go to enable WAN management on there, is it will suggest to not use that. It is still very highly suggested to not expose the management interface of your firewall to the internet. They already get enough information on there, so why provide them a login forum where they can try logging in like VPN options. So our three main ones is the IPsec policy-based, IPsec route-based, and SSL VPN. Site-to-site, I just put that in there so it doesn't get confusing about the other one. Usually people think of SSL VPN as a client remote access. So let's compare policy versus route-based. Policy is a site-to-site or host-to-host on there, whereas route-based is VPN. These are commonly what they are referred to as, is the site-to-site for policy-based and tunnel interface for route-based. With the policy-based, you get a single IPsec interface. You do not see this in the XG firewall. You can see it when you go into the CLI, but this is mainly just used for internal routing purposes. With the route-based, you get an XFRM interface on there that is configurable, that you can put an IP on and you can route traffic to it. This is also a selectable gateway. For the number of VPNs, policy-based comes ahead on that, where it creates a tunnel for each local and remote subnets. So if you have two local subnets in the policy-based VPN and one remote, you're going to end up with two security associations in there. So if you have 5 local subnets and 5 remote subnets, then you'll end up with 25 security associations. Those security associations each have their own tunnels inside of the main phase 1 tunnel. This causes a little bit more overhead on there and utilizes more resources, whereas the route base creates one single tunnel on there for the entire routed network. So depending on your situation, you may want to choose route-based over policy-based based off of this information. Now, when it comes to adding new networks to the VPN, policy-based does require downtime. And I'm not saying minutes of downtime, I'm just saying a few seconds. Whenever you make a change to a policy-based VPN, one of the phases is going to go down because now it has to do a whole new renegotiation and reassignment of the security associations. Whereas the route-based, there is no downtime. All you have to do is just change your routes on there, and now you're good. Policy-based, there's no granular control over the routing. When it receives traffic, the XG firewall that is, it will route it to where it needs to go. That's what it will do, based off of the policy. Route-based, you have a lot more granular control over everything. You can send traffic where you want, you can choose not to send traffic there, you can set metrics on it. So it gives you a lot more granular control over what you're doing on your VPN. So let's go over some more route-based information. So with routing options, you have static routing, then you have dynamic routing with supported protocols on the XG firewall like OSPF, BGP, and RIP. And you also have SD-WAN routing. This is a new thing out there and we support it. And as I said before, is when you create a route-based tunnel interface, there is an XFRM interface that's created for each policy on there so that you can route traffic to and from that interface. As you can see in the image on this screen, there is a route precedence, and we provide this to you, and it's configurable via the CLI. That'd be option number 4 in the CLI. And you can see the precedence by default is static routes, SD-WAN policies, and then VPN routes. Now let's talk about SSL VPN, the site-to-site one. It is a client-server configuration, so you can kind of still think about this as if it is a remote access, but this is more of between two appliances. So you configure one to be the server and the other to be the client, the initiator. This is very useful for when IPsec is not working. There are still ISPs out there and vendors where they block IPsec. They're blocking 15500. So now, since SSL VPN looks like HTTPS traffic, you can get through this issue and not have to worry about it. Now, if you're in a secure environment and you have access to an HTTP proxy server, you can utilize that as well to create the outbound connection on the client side. So when to use what type of VPN? So for policy-based, you're looking at generally a small network, maybe one network on each side, not looking to really expand anything. Maybe that appliance locally is not going to really change. No networks are going to change. Nothing's really coming. It's very static, so you don't have to worry about it. Route-based, you're looking at generally larger networks, rapidly changing networks, the cause for having dynamic routing, having dynamic redundancy, or if you want to utilize SD-WAN. This is also where if you really want to have granular control over your traffic on your VPNs, this is also the best choice. And for the SSL VPN, as we just discussed, it's really there for when IPsec does not work. If it's being blocked, or there's restrictions someplace, or you're just having issues with setting up an IPsec VPN, just go ahead and set up an SSL VPN and see if it works. In the XG firewall, we also have IPsec failover groups. This is where we can fail over from a primary to secondary when the VPN goes down. The XG firewall will periodically check every 60 seconds to see if the primary VPN is back online. Then you can fail back over to the primary VPN as it is the chosen one. You can have several in there, and this really is one of those good ones for when you have multiple WAN and maybe you're having VPNs up to cloud services like AWS or Azure. You can always ensure that you're on your fastest, most reliable link on those VPNs, but while ensuring that you still have access to your cloud resources over a secure connection. Let's talk about the remote Ethernet devices, or RED. Sophos has the SD20Ws and the SD RED 60Ws. They are the wireless models and non-wireless models of them. These devices are capable with the firmware on 17.5 MR11 and up, and 18 MR1 and up, and also the UTM 97 MR3. These wireless models are 802.11ac, or also referred to as Wi-Fi 5. These are nice little devices that come in handy when you want to deploy a device remotely. When you have users at a remote location that may not have any technical resources there, you can set these up with the XG firewall, and once they have internet, they'll reach out to a provisioning server and then configure. And that's it. All the user has to do is just plug in some cables and they'll create a VPN tunnel back. Now there are a couple modes for this. The first one we're going to talk about is standard unified mode. This is where the XG firewall is managing the LAN. This is basically where that red device that you have put in that remote office is now routing all of the traffic back to the XG. This is where it will handle all the security and traffic. Any traffic destined for the internet will still go through the red tunnel back to the XG, have security applied to it, and even web filtering, and then go out to the internet. The other method is standard split mode. This is where the internet traffic will go out the red device itself. It will NAT out the public IP that is provided on its WAN side, and then take all the LAN requests and send it across the red tunnel to the XG. This will be for something where you don't really need to provide any security on that interbase traffic, or bandwidth is a limitation there, and you just want to utilize the local internet to offload all of that. And the last mode is transparent split mode. So this is where you're putting a red device behind an existing router or firewall. This will be transparent to the network, as in it will only act on the traffic that is destined for the LAN networks at the XG firewall. All their traffic will just be passed through untouched by the red device. Let's talk about some best practices for site-to-site VPN. Just like the remote client access, we would suggest using digital certificates when possible, and use long randomized PSKs. The XG firewall also has an RSA key defined that you can also utilize for this purpose. For crypto options, a lot of people just go and configure and utilize whatever the default is. And so folks, that's correct, as we use what I consider is the best practice for the cryptography settings. Using DH group 14 or higher. Higher isn't always better, as some of the encryptions are less, but in general sense, it is. I would just suggest saying 14. On the XG firewall, this will tell you when it is suggested to use a higher level. This goes with the encryption and authentication as well. For encryption, we consider AES 256 or higher to be pretty secure while ensuring performance. Same thing with authentication. SHA-2 256 or higher is really good as well. Now this comes with planning and testing. These encryptions may be what I consider the best, and what Sophos desires you to have configured on your device to ensure the security of your traffic. But you need to plan this implementation of saying, hey, this is you and this is me, and identifying yourself. It's just another layer in there. Trying to provide identification in layers is really good. It's really ensuring that when you're sending those packets out to those IPs, that they are arriving where it is, and then you're providing a secure tunnel. Or secure tunnels are opening up your network to that other side. You want to ensure the other side is the person that you're trying to talk to. Now let's go ahead and take a look at some configurations. I'm going to go ahead and create a tunnel interface connection between two XG firewalls and configure an SD-WAN routing configuration. Okay, now I have a diagram here of the two locations, just so you can see. For reference, we're going to have two XG firewalls at each end. There's going to be an MPLS link between the two with these IPs. Then we have the tunnel interface VPN. There's the main office, and there's the remote office. And these are our two clients that we're going to be testing against. Let's get in. Here's our main office firewall. This is an XG 230 running Sophos 18.04. Let's go to the VPN. As you can see here, before I get started, I already have some VPNs created. As you see, having a tunnel interface running an IPv2 template policy to pfSense. I have a custom IPsec policy to a sonic wall. I also have another site-to-site to a UTM running 9.7. Just go take a look at that sonic wall's IPsec policy. As you can see, the XG firewall already has a bunch of predefined IPsec policies, but there are some devices out there, like a sonic wall, that only like one crypto suggestion. They do not do groups-based suggestion, and if you try to do that, you end up having bad VPN tunnels or unstable VPN tunnels. So we just mirrored the configuration off of there. Let's take a look. As you can see here, I called this the default sonic wall 6.5. This is not a built-in one, this is something that I built. This one is for an IPv2. And as you can see here, the default at the time is the 6.5 firmware on a sonic wall utilizes DH group 2. It also uses authentication SHA-1, and it's AES 128. As you can see, the Sophos XG firewall is saying, hey, we don't like this. You should really honestly use something better. And you can see here on this flag, this configuration is not recommended. It is potentially insecure. This is something that, if possible, if you have access to the device, to go and change the encryption if possible. And if it is someone else that you're connecting to, another organization, maybe talk to them. Maybe they don't know that that is potentially insecure and they should change it. Maybe it's just another network admin on there that was told to set up a firewall. And that's the sonic wall default policy that I have created on there. Let's go ahead and create that IPsec connection, that tunnel interface to there. Let's go ahead and add. Let's call it to remote office. We really like adding those underscores in there to make it more readable. Let's change connection type to tunnel interface. Change from dual to just IPv4. Why allow both on there? Or I'm just going to be sending IPv4 traffic. Always be very specific when possible. Really big thing in security. We're going to set this gateway type to respond only. There is another one of initiate connection, so one side is going to be the other. So in this case, the remote firewall is going to be the initiator. Let's go ahead and check the box for activate on save. This means once I click the save button after I'm done configuring this, it's automatically going to activate this VPN. It's not going to wait for me. We're going to do IPv2 policy. Let's go ahead and use that RSA key. And let's save this. Now, this is red because we need the other RSA key. Let's go ahead and get into the other one. Let's look at the remote office firewall. Let's go to add. And let's call this to main office. Let's also set its connection type to tunnel interface, IP version to 4, and activate on safe. Change its gateway type to initiate the connection. We'll also use the predefined IPv2 policy. Let's change its authentication type to RSA key. Let's go ahead and take the other key that we took from the other firewall and add it in there. And let's take this key, go to the back to the main firewall, and add it in there. Now let's continue configuring the main office firewall. Let's set the port 2 as per the diagram. We're using this interface, and then let's do the remote access of 10.10.1217. Let's just double check and make sure that's correct. Yep. Now As you saw before, my best practice suggestion was to set local IDs. So let's go ahead and do that. Let's do IP address for each of them. Now some of these, I like to really just keep it simple and just use the LAN IP addresses on there. It can be anything really. I just like to keep it straightforward and know what is there. Now you can see the local subnet selections are all grayed out because this is a tunnel interface. The access will be provided via the access rules and the routes. So let's go ahead and save this one on the main office firewall. While that's activating, let's go back to the remote firewall. Let's finish configuring this. Select port B, 10.1253, and let's set its ID types. Set this to the interface. And just double check that everything is correct on here. Initiate, IP, activate on save. We have the RSA key, listening interface. We have the correct IP as a gateway. Now we have the IP addresses in here. That's all good. Let's go ahead and save this. Oh look, green on green, up on the first try. It's good. I've already created the firewall rules on both the devices to ensure that everything runs smooth and to save some time. So let's go ahead and create the routes needed. We're going to use SD-WAN. So let's go to routing and SD-WAN policy routing. Let's go to add. As you see, there's gateways required. Let's go check that. Let's go to gateways. We already have the gateways configured here. As you can see, they're checking and validating. These are green. So we're good. Let's go configure that route now. Let's call this do remote office LAN. Keeping it very descriptive. You have a description field if you really want to fill that out on there to give a little bit more detail, just like really putting in as much precise information as I can in the naming scheme. Let's go ahead and select port 1, as that's the traffic incoming interface. We're going to define this as the LAN. Apply, and destination network. This will be the remote office. Check that. Remote office LAN, apply. You can also do application objects in here if you'd like. Let's just take a look at this. You can create many different objects in here based off of applications. And with synchronized security, you can do it even off of the cloud ones. So if you need to route certain things across the VPNs, you can do that as well. Now let's select the gateways. Since most cases the MPLS network is generally more reliable, faster, less overhead, let's go ahead and set that as our primary gateway. And the backup gateway, let's go ahead and set that to the tunnel interface. So let's create that remote office. And we're just turning this down just for the demonstration. Generally, 30 seconds is good enough on here, but we just want to ensure that when I do some testing, that it reacts faster. And now we're not sitting around waiting. One of the things that we have to do on here is apply an IP address to the XFRM interface that was created. I really like to just rename these back to what that is, whatever IPsec it is. It's just something I do just so I know when I'm looking through on the list that I can tell which one it's directly associated with. Let's refer back to the diagram on what IP we are supposed to be putting here. the 10.77.2. And we're doing a /30. Save. Now that we have that XRFM interface with an IP on it, we can set up its gateway. Let's set the primary to MPLS, and let's create new for the backup. Now you can see two main offices. I want the gateway IP to be pointed at the other side. Once again, let's set its interval to 5. Let's save. We have successfully created the route. Now let's go back to the main office. Now you can see here in the SD-WAN policy on the remote office, there's a green dot. When you hover over it, you can see the primary gateway and the secondary gateway, or the backup gateway. And you can see the current status of both of them. They're currently up. So that means the traffic will now route over the MPLS, and then it will route over the VPN connection. Let's go ahead and go behind one of the client devices behind the XG firewall at the main location. Do ipconfig, that's its IP, 172.16.16.18. Now let's ping the remote side, 172.18.1.3. Hey, we can ping, successful. Now, let's go ahead and simulate if the MPLS went down. Since my remote firewall is a virtual appliance, I'm just going to go into the hypervisor and disconnect the interface. 1 second. As you can see here, the MPLS interface on the remote office firewall is unplugged. Now that connection is down. So now let's go over to the main office firewall and take a look at the SD-WAN routing policy. Now let's go ahead and check the gateways. As you can see here, the status for the one for the MPLS is now down, but the one for the VPN is still up. Now per our SD-WAN routing policy, we should still be able to reach the other network. Let's go to the main office client and take a look. Let's see if we can ping. We can still ping. That means the SD-WAN routing policy is working as expected. There's a lot you can do with this, and this is just a simple ping showing of an MPLS network and a tunnel interface. You can get very complex with using VoIP, using a lot of QoS on there, and even just simple things like ping, like I did. To get more information on some of the topics that we've gone over,